All right, everybody, welcome to the video here for weekly review number 3 for the Algebra 2 Regents exam. So the big concept in this review is, can we use the quadratic formula, and can we use it when there are potentially complex solutions? So a couple things that we have to remember when doing the quadratic formula. One, the formula itself is on the reference table. So there should be no reason that we actually have the formula wrong. We don't have to memorize it. It's right on the reference table for us. So if we're plugging into the wrong formula, that's an us issue. That's not anything else that we can be concerned about. So in the quadratic formula, there are 3 parts, A, B, and C. In every single quadratic equation, there is an A, which is the coefficient to x squared. There is a B, which is the coefficient to x, and there is a C, which is our constant term. They're usually equal to 0. If they're not, we have to make them equal to 0. So let's take a look at this first one. So because this is multiple choice, we want to try and eliminate choices. And just a general test taking tip, if we're not really 100% sure what to do, graph what you have. So if I go to Desmos and I graph that equation, so if I go to Desmos here and I graph, let me just move this out of my way. Also, if I graph 2x squared plus 3x plus 2, I see that this parabola does not touch the x-axis, meaning it does not have any real zeros. It still has zeros, they're just not real, which means if they're asking for these solutions, these zeros, and it doesn't have I in it, it can't be the answer. I've just eliminated 2 of my 4 choices. So let's actually plug in then and see which of these remaining choices is correct. So in this equation, our A is 2, our B is 3, and our C is also 2. So when I plug into the quadratic formula, we have the opposite, or negative b, plus or minus b squared minus 4 times 2 times 3a and c, all over 2 times 2, because that's where a is. Now, in the quadratic formula, this part underneath the square root symbol has a name. It's called the discriminant. And we want to evaluate that first. That's also going to tell us whether or not our solutions are real or not. So if I type that into my calculator, so if I type in 3 squared minus 4 times 2 times 2, I wind up getting negative 7. That is not a 3, that is a 2. AC, there we go. So we have a 2 there. Now we're cooking. And we get negative 7. Now, because this is a negative value, that tells us also that the solutions are not real, further telling us it's either A or B. So now we have to figure out, what do we do with this? So in class, what we always said to do is kind of break apart this top. So this top is separated by this plus and minus, almost like creating 2 fractions. So I have the fraction negative 3 over 4, plus or minus the square root of negative 7, which is also over 4. Notice I'm kind of like sharing the negative 4 with the part before and after the plus and minus. Now, because that square root has a negative in it, we can get rid of that negative and make it into the imaginary unit I. So we have I squared of 7 over 4, because we remember that I is the same thing as the square root of negative 1. So we get answer A. Now that looks a little different, and that's because there's really a 1 here, which makes the fraction 1/4. Same thing. All right, let's take a look at the next one. Set up almost identical to the first one, but with just bigger numbers. So again, in this case, the A is 18. The B is negative 24. The C is 87. Again, I would probably graph this first to see, but if you look at your choices, they all have I in it. So the graph's really not going to help me too much, because all of them are going to have the imaginary unit in there. Therefore, this graph is not going to touch the x-axis. So we could just jump right to the quadratic formula. So we could say x equals the negative or the opposite of b, so 24, plus or minus, let's plug it in right this time, negative 24 squared, use parentheses when you have negative numbers, minus 4 times 18 times 87, all divided by 2 times 18. So now I got to figure out what that number comes out to be. So let's go back to Desmos here. Let's get rid of this junk. And we'll type in our negative 24 squared minus 4 times 18 times 87. And we get this really big number, negative 5,688. So the discriminant is a negative number, negative 5,688. So when I start breaking this up, I'm going to have x equals 24 over 36. 2 times 18 is 36. Plus or minus the square root of negative 5,688 divided by 36. So I could eliminate some choices. It can't be choice A or B based on the fact that the first fraction is positive. And 24 over 36 does reduce to 2/3, so we can kind of just go ahead and put that in there. If you don't know why it reduces to 2/3, go to your calculator, type it in, 24 divided by 36. It'll give you a decimal. Hit the little fraction button. It tells you 2/3. Now, let's deal with the radical. So whenever we're simplifying radicals, we want to try and find the largest perfect square that's a factor of the discriminant number. So we already know it's going to be I. So let's get rid of the negative first. And now we want to try and find two numbers that can multiply together to make that 5,688 number, and one of them being a perfect square. Now let's cheat. What do you notice about your choices? They all have the same number in them. So I'm going to type that number in and see what happens. So if I take 5,688 and divide it by 158, that weird number that was in there, notice the other factor is 36. So now we know that 36 times 158 gives us that number we're looking for, and 36 is a perfect square. So I can use that in my problem. So I'm going to say, all right, so I have 36, which is a perfect square, times 158. Well, that simplifies because the square root of 36 is actually 6. So we have 6i square root of 158. So now we just have to figure out which of these choices that are remaining make this fraction 6 over 36. Right, because I can't simplify the 36 into the 158 or to the I because they're not like terms. The 6 and 36 can be simplified. Well, 6 divided by 36, if you're not great with fractions, is going to be a fraction, and it's going to be 1/6. So now we know the answer is D, because that's the only one with 1/6 there. That's left after we eliminated those first two choices. Okay, so now we have a free response question. They're giving you a huge hint here. They're telling us that the answer needs to be an A plus BI form. Well, that's telling us that we have this quadratic that's going to have a imaginary solution. So look for that. If you're not getting that, you probably messed up somewhere with your numbers. So again, it's quadratic formula. 2 is A, B is 5. Luckily, these are smaller numbers to deal with. And C is 8. So we can say x equals the opposite of b plus or minus b squared minus 4 times 2 times 8, all divided by 2 times 2. Again, let's figure out this discriminant number so we could see and prove that it is going to be an imaginary solution. So if we go to our good friend Desmos again, we have 5 squared minus 4 times 2 times, what was it, 8. And we get negative 39. So because that's negative, that's telling us we don't have x-intercepts, we have non-real solutions, and we can move forward and try and put this in the right form. So again, we want to share that denominator with both parts of the numerator. So negative 5 over 4, 2 times 2 is 4, plus or minus. So we're kind of splitting the fraction where the plus and minus is. We have the square root of negative 39, which is also going to be over 4. Now, this is a good answer, but it's not in the form that they want. They want it in a plus bi form. So I got to simplify this square root of negative 39. Well, that's going to become I square root of 39. And then there's no perfect square that's a factor of 39, so that's actually simplified. So we could say x equals negative 5 over 4 plus or minus I square root of 39 over 4. This is an acceptable answer. Not the one they want, but it's acceptable. They'd give you full credit for that. What they actually want you to write is negative 5 over 4 plus or minus the square root of 39 over 4, and then put the I at the end. So you could distinctly see that the A is negative 5/4 and the B is the square root of 39 over 4. But either way, it's good. Let's try this last one. This is got multiple parts. This is definitely more than a 2-point free response question. If I remember correctly, it was a part 3, so this is worth 4 points. So it says algebraically determine the roots in simplest a plus bi form to the equation below. So let's do part A first. So this is not set equal to 0. So that's going to be our first job. I'm just going to rewrite it here so we can do some work. So I'm going to move the 10 by adding it to the other side. And I'm going to move the 4x by subtracting it to the other side, giving us x squared minus 6x plus 17 equals 0. Now, again, they're giving us a big hint by saying that the roots are in a plus bi form. So that tells me don't even try and factor this. There's going to be no numbers that multiply to make 17 that add to make negative 6. It's going to be quadratic formula. So let's do that. So we can say x equals the opposite of b, which is positive 6, plus or minus b, negative 6 squared. Remember, negatives go in parentheses, minus 4 times 1 times 17, all divided by 2 times 1. So we can separate my fraction up and figure out what this discriminant value is. So if we find the discriminant here, we have our negative 6 in a parenthesis squared minus 4 times 1 times 17. And we get negative 32. So we have the square root of negative 32. So that tells us the solutions are non-real like they said, but now I have to deal with this number. So the square root of negative 32, we can make I square root of 32. And then we could try and simplify that to find a perfect square that's a factor of 32. There's 2 of them. I want the biggest one. 16 and 2 is what I want. I don't want 4 and 8. So the square root of 16 is 4, so we have 4i square roots of 2. So that can be replaced right back in there where that was. That is equivalent. So we could go ahead and rewrite this as 3. 6 over 2 is 3, plus or minus 4i square root of 2 over 2. But 4 and 2 can reduce, so the best possible, simplest answer that we can give would be 2i square root of 2 for that last part. So 3 plus or minus 2i square roots of 2. All right. Part B says consider the system. And then it says for part C, the graph of this system confirms the solution to A is imaginary. Explain why. So what did they want you to say for part B for considering the system? Well, it's a system, so let's graph it and see what happens. So if we graph y equals x squared minus 2x plus 7. And then we graph y equals 4x minus 10. We will notice that this system of equations is a quadratic linear system that has no intersections. So what we could say for B is it is a quadratic linear system with no intersections. They're just asking you to explain what you're seeing. Part C says the graph of this solution confirms that the solution in part A is imaginary. Explain why. What we can say is systems with no intersections have non-real solutions when solved algebraically, which is what we saw. Because even though these look different, this is how we would solve that system, right? If you solve a system, you replace y with what it's equal to, you'd set these equal to each other, which is what they did in step A. Kind of an odd question. They're asking you to explain a bunch of stuff. The math part should be pretty straightforward. Can you plug into the quadratic formula? I'm hoping this helped. Again, keep studying, keep looking over your notes, and get ready for your weekly quiz.